that. Now, I think I got a question from this class. I won't mention their name because I don't want them to get beat up by the rest of the people that don't want to communicate. So I think we got one. I'm not sure. Let me look right quick. Because y'all aren't supposed to send me any kind of communications. Y'all supposed to be quiet. This pact y'all took. Right? To not communicate.
Oh.
I thought y'all took a pack. There we go. 5.3648. 5.3648. 5.364/8. And y is equal to negative x squared plus 100. I'm not going to do anything else. Why? Somebody tell me why I'm not going to write anything else down. Because what do we need
most
to
of it's
do?
already given.
I'm sorry, what?
Most of the problem is already done.
Well, we need to, whenever we're confused, what should we do?
We should give up.
Well, yeah, that's the first thing you should do. Always give up. Giving up is a good thing because you're never going to be much more than a janitorial office with a piece of plywood over the sink. Okay? But those of you that's not going to give up, what should you do when you're confused and you don't have any idea what to do with the problem? You reach for the good old graphing calculator, and what do?
Graph it.
You graph it. Why? Because you need to see it. So that's the first thing to do. Of course, this is a circle. I'm going to go over here. And it looks like that. How do I know? Because x is what? Negative. So somebody tell me what the x-intercepts are. Right quick. You don't need the graphic calculator to tell you that. What's the x-intercepts?
Would it be positive and negative 50?
Not 50. You divided 100 by 2. You're supposed to take the square root of 100.
Negative 10 and 10.
Negative 10 and 10. What section are we on in calculus right now? Finding the what under a curve?
Area.
On the area.
Finding the area under a curve. So we're going to set this up as a what? As a integral. Definite. Now there's two ways to set this up. Can somebody tell me what are the two ways? You don't have to be all mathematical. You just tell me how you could set it up. There's two ways. I'll give y'all about 5 or 10 seconds. Somebody that wants to, stick their neck out. I know you're not supposed to communicate with me, but, somebody that wants to feel good about themselves. Anybody?
You can put it with numbers or without numbers.
Mr. Padiella, you're such a disappointment. I don't know what I'm going to do with you. I'll probably fail you. What do you notice about this drawing? What do you notice about it? Somebody tell me what
It's
you notice
symmetrical.
about it. It's a circle. But what do you notice about it?
It's symmetrical.
It's what? Symmetrical. Write that down. It is symmetrical around the what? Around the y-axis. This is a mirror image of this. So when you have symmetry There's two ways to do the problem. Now, does that knock some cobwebs loose? What would be the two ways? Well, which way do we read?
Left to right.
So the area of the left side is from -10 to 0 of -x squared plus 100 dx plus, somebody give me the second part.
Right to left.
0 to what?
T
0 to what?
To 10.
To 10 of -x squared plus 100 dx. All right, that's one way. Now, somebody tell me the other way you could do this problem, since it is symmetrical. And since one side is the same as the other side. Y'all can't see it. I mean, if you get the area on one side, what could you do with it? If you got two sides that are the mirror image of each other, and you get the area of one side, what can you do to get the area for both sides? Multiply by what?
The same thing you did get the first one.
Multiply by 2. So which side am I going to pick? Am I going to pick the area? Am I going to do the area on the right side, or am I going to do the area on the left side? Somebody tell me what you think I'm going to choose. You got a 50-50 shot. Side. What?
The left one.
Am I going to pick the right side, or am I going to pick the left side?
Left.
No, I'm going to pick the right. Somebody tell me why.
Because that's where most of your it's where the excess is, right?
Not really, because you got x's on this side. I think you're thinking about the first quadrant, and that has a little bit to do with it. Anybody else want to take a guess? Why did I pick the right side? I could have picked the left side. Why did I pick the right side?
Both your x and y values are positive on the right.
And 0 takes out itself, so I just got to deal with what? 10. Well, 0's on the other side, Hubert. Yeah, but what are you dealing with here? Negative 10. If you like whips and chains, knock yourself out. But I don't want to deal with negative 10 when I got an option to deal with positive 10. So that's the two ways. Now, this is kind of also what they do in 5.4. 5.3 and 5.4 talk a lot about symmetry. And that's what you need to know about symmetry. If you've got something, if you've got a drawing and it is symmetrical, then you can actually do the easier of the two. Okay? Hold on just a second. I'm sorry, I got a cat that's beating up on another cat. Sorry. All right, so I'm going to do this. If you want to do this, knock yourself out. I'm not going to do it. but we're going to do this one. Okay? So I'm going to go to the next page. And we're going to do, oh, and this is a test question. Why is it a test question? Because you're doing, you've got a nice function here, and you're going to take the antiderivative, and you're going to plug and chug 0 and 10. This is a test question. So 2 times the antiderivative from 0 to 10 of negative x squared plus 100 dx. I want to find the area of the height times the base from 0 to 10. In order to do that, I've got to take the antiderivative. So that's going to be 2 times negative x cubed over 3 plus 100x evaluated at 0 and 10. And what does 0 do to this whole thing?
0.
Zeros it out, cancels it out. So I'm going to take my red pen. Now, it's not going to do that all the time, because sometimes you might have a plus 3 out here, like x cubed plus 100x plus 3, and 0 doesn't cancel out everything. But in this case, since there's 2 x's and 2 terms, the 0 cancels it out. So that means all we got to do is plug in 10 and multiply it by 2. So negative parentheses cubed over 3 plus 100 times parentheses. And that's going to be 10 and 10. And that's going to be negative 2, negative 1,000 over 3 plus, well, that's 1,000, but you got to put it over 3,000. So that's going to be 3,000 over 3. And that's going to be negative, or 2, sorry. 2 times, and what is negative 1,000 plus 3,000? 2,000 over 3, and that's going to be 4,000 over 3 square units. Now, if I was to give you 10 questions for the unit or chapter 5 test, 8 of them would be like this. This is a test question. This is not hard, people. Now, this question, Mr. Smith, I think, asked this question. They asked you for this, and then I don't know if they asked you for this or not, but then they're going to ask you for the answer, probably in fractional form. So let's see what they asked for. I'm not going to type all of it in. 3, 3, 3. Oh, the heck with it. I'm not doing all that. Just answer it and get a wrong answer. Okay. And there is our answer right there. I got 4,000. What'd I get? 4,000 over 3. And the area is 4,000 over 3. I love that question. Okay. Anybody got a question on that one? That's a good one. All righty. Now, I'm going to kind of skip over 5.4 because it's a lot of what we just did there. I want to get to 5.5. Now, why am I skipping and getting to 5.5? Because looking at your homework, I'm going to write this down for you. 90% or 80% of your test, chapter 5 and 6 test, 5.1, 5.2, 5.3, 5.4, 5.5, and 6.1 right now. I don't know how far we're going to get in chapter 6. 90% of your test is going to come from 5.2, I think. Which one is the power rule? That's 5.3, isn't it? Yeah. 5.3, 5.5, and 6.1. That's where 90% of your test is coming from. 5.3, 5.5, and 6.1. Now, 5.3, that encompasses the symmetry. Okay, that's in 5.4 because it's basically the power rule of integration and plug and chugging. Okay, so, if you can do the symmetry problem like I just did, then you can do 5.3. 5.5 is substitution. Substitution is 100% critical for you to be able to stay in Calc 2. Notice I said stay. I didn't say pass. I said stay in Math 141. So we've got to get on this and we've got to work this. Everybody with me? So these two right here, 5.3 and 5.5, they are critical. So let's get started. Well, so far, we have taken the antiderivative of a term or several terms, 2x squared plus 3x plus 4, and that's going to be a dx. We know how to take the antiderivative of 3x to the 4th dx. We know how to take the derivative of the square root of x dx because you've got to rewrite it as 1/2 x. We know how to take the antiderivative of x to the -3 dx. Okay, we know how to do the basics, and this is the power rule. Okay, that's 5.3, I guess. Now I'm going to throw a couple of these in. There's the derivative of the log. Let me throw those in too. And y'all got it on y'all's little sheet that I sent y'all either today or yesterday. The antiderivative of 1 over x dx is equal to natural log of x plus c. So therefore, if I give you the antiderivative of 7 over x dx, then that's going to be 7, and antiderivative of 1 over x dx, which is 7 times the natural log of x, or 1 over x, sorry, of x, sorry, plus c. Okay, so And then if I gave you the antiderivative of 1 over x plus 5 dx, well, that is the natural log of x plus 5 dx. I'm sorry, plus c. Okay, so there's a little bit of a taste of a natural log. And of course, you've got the natural log on your cheat sheet. But I just wanted to make sure you understood that you don't use the power rule with the natural log. You just take whatever, pull it out, and then do 1 over x, or 1 over x plus 5. Same thing with your exponentials. Antiderivative of e to the x is dx is equal to e to the x plus c. If you have the antiderivative of e to the 2x, that's equal to e to the 2x divided by 2, which is the derivative of what's inside. Yes, that comes from the chain rule. If I give you the antiderivative of e to the negative 5x, that's equal to e to the negative 5x over negative 5. So there's some kind of in-between antiderivatives that are on your cheat sheet. And hopefully you can just look at those and write some down. You might get some in your homework. But substitution, what is substitution? Well, substitution is used when the problems get a little bit more difficult. What do you mean, Hubert? Well, let's say that I give you something like this. Antiderivative of 2x times x squared plus 4 to the 100th power. Okay, first of all, you notice that you are multiplying something times something else. So you don't have, you also notice that you've got something in parentheses raised to the 100th power. So this is more what? Complicated. Now, the first thing I tell students to do with the substitution rule, and of course, half of y'all are going to follow my directions, and half of you are, you don't need to because you invented calculus. Okay? But what I tell for those students that really suck at calculus, I tell students to rewrite, number one, rewrite with less complicated with the dx. All right, so somebody tell me, you got two terms here. You got 2x and you've got x squared plus 4 to the 100th power. Which one is less complicated?
2x.
So I'm going to put that 2x beside this dx, and I'm going to rewrite this. X squared plus 4 to the 100th power, 2x dx. Okay, now this is where we're going to take the red pen and we're going to put number 2. Let u equal the most complicated part. Now, how many of you play a musical instrument? Anybody?
I do.
Oh, there's somebody in here that plays a musical instrument. Bring down those cameras from the ceiling fans and the ceiling, and let me see somebody that plays a musical instrument. Okay, Mr. Nicolini, what do you play?
I play a tiny bit of guitar. I'm not very good though.
Well, you know how to hold your fingers, right, on the fret?
Yeah.
Are there different ways to hold the fingers on the frets? I mean, do you have to, does Eddie Van Halen and Slash, do you think they hold their fingers exactly the same way when
No.
they play their guitars?
No.
Why? How do you know that there's different ways to hold your frets? How do you know that?
I don't know if I. What do you mean?
Come on, tell me why.
Because it's
How
just what
does
I'm comfortable with.
How does somebody that plays like Eddie Van Halen and Slash, how do they get by with holding their fingers however they want to?
They're really good and they practiced a lot.
Whoa, what'd you say?
They practiced a lot.
They practice. So how do you know which one's the most complicated part? By doing these problems and practicing. All right, the most complicated part of this problem is inside the parentheses. Now, is that going to happen all the time? A good portion of the time, yes. Not all the time. So I'm going to let U equal, and I'm going to do it in my green and my orange, and I think my voice is leaving me. I don't know what's going on with my voice. I'm trying to find my fluorescent green pen, and I can't find it. Damn Russians. I'll have to use this one. This is that. Oh, there it is. Okay, and my orange pen. So I'm going to go over here. U equal x squared plus 4. And then I'm going to take the derivative of that. Du is equal to 2x dx. Where do we see 2x dx?
In the original problem that you set up.
So somebody tell me, it looks like to me, we've got the antiderivative of u to the 100th power du. Now I want you to look at that and to make sure you understand how I got this. This is u, and what's the derivative of u? 2x dx. Then that's, so I've got u to the 100th power du. Does everybody see that? So what do we need to put
Yes.
somewhere that's very, let's see, I got to find a fluorescent color that will stick out. Let's go with this blue. I don't know if it'll stick out enough. This has to match this. What if it doesn't? Then you got to make it. Now this one, do you remember elimination method? When something didn't fit, you made it fit. Do you remember doing that in elimination?
Yeah. Well,
Okay, let's go back. Let's go back a little bit. (2x minus 3y is equal to 7. 4x plus y is equal to 8. What did we do to this second column, the second row, to make the y's eliminate?
Multiply by negative 3.
Multiply by negative 3. All right, so you manipulated the second row by negative 3. So you're going to have to use that same mentality if this doesn't match that. Does everybody understand what I just said? Because that is the secret to the substitution method. If you don't have this, if they don't match, you got to make it match. If you can't make it match, then you can't do it. Now, all of these problems that I'm going to show you, you can. This one, you don't have to make it because it matches. So you have, so what is the antiderivative of u to the 100th power? That means I want somebody to say something. What is the antiderivative of u to the 100th power? Y'all don't know your power rule of what do? You raise the exponent by 1 and then what? Did we not go over the power rule of antiderivatives? Is anybody going to say anything? Mr. Lowry, did we go over the power rule?
I got here at like 12:20, so I have no clue.
Mr. Nicolini, did we go over the power rule? Okay, I guess we didn't. The power rule says if you have antiderivative of u to the n, or I'm sorry, if you have the antiderivative of x to the n dx, in other words, if this is the derivative of this, then you have x to the n plus 1 over n plus 1 plus c. Did we not go over that?
Mm-hmm.
Yes or no?
We did yesterday, but it was very brief.
Okay, very brief. Thank you, Mr. Piella, for communicating. We're going to have to give you a bronze star because you're doing such a painful thing communicating with me, Mr. Piella. Thank you.
Gold. Why not gold?
Huh?
Why not gold?
Them dang old girls taking gold and silver over there, dang old track. Dang old, they doing good. Gold and silver. All right. So this is the power rule of integration. I watched a lot of them Olympic things, but then some of them started being stupid, so I turned it off. As soon as they start being stupid, I turn it off, or I cover up that part with a towel. All right. So anyway, to make a long story short, there's u to the n, so you're going to add it. So here, that's going to be u to the 101 over what? 101 plus c. And now all you do is you put u back into the equation. Parentheses, x squared plus 4 to the 101 over 101 plus c. This is an example of substitution when the derivatives match up. Okay, I'm fixing to do one kind of like this one, where the derivatives do not match up. And we're going to do like 10 problems the next 2 days. I mean, not tomorrow, but Monday. When is July 4th?
Sunday, isn't it?
Huh?
Sunday.
Oh, so that means we don't have
Monday,
class
yeah.
Monday. Somebody look in your academic calendar.
We don't have class Monday.
Okay.
Yeah, we won't be back in until Tuesday.
Okay, so try this one. The antiderivative of x squared plus 5 raised to the third power 4x dx. I already moved it for you. All right, take a look at that one. Find out what u is. Take a minute or two. I'll give you a couple of minutes. I'm going to step away for a second. Okay, so I've already put the 4x over here. The original problem looked like this. The original problem was the antiderivative of 4x, x squared plus 5 to the third power dx. And I wrote it like this because I want this together. Now I'm going to tell you something. There's a lot of calculus teachers that do not tell you to do this. And that's why a lot of students don't grab this when they do substitution. Anybody that's had calculus before, it helps to put that 4x right there. So I'm going to go over here and I'm going to say u is equal to x squared plus 5. Du is equal to 2x dx. Do we have 2x dx?
No.
No. So we quit the problem and go to another problem, right? No, we don't. We put a 1/2 here and a 2 here. Now somebody tell me why I just did what I did.
So you get them to equal each other?
So I get, what's 1/2 times 4x?
2x.
2x dx. So whatever I put here, I've got to put the reciprocal outside. Now that reciprocal is going to stay. This is u to the third du. I'm going to rewrite it now. And I'm just going to rewrite it for those that need it. And I'm going to keep that 2 pink because it has to stay. Antiderivative of x squared plus 5. And now 1/2 4 is 2x dx. And now I have u to the third 2 times the antiderivative of u to the third du. U to the third du. Okay, finish it out now. All you got to do is take the antiderivative and plug and chug what u is and simplify it. So what is the antiderivative of u to the third?
X squared plus 5 to the fourth over
U
4.
to the fourth over what?
4.
4. And now I'm going to plug that in. I'm going to plug u to the 4, or whatever u is. And 2 over 4 cancels to what? That 2 will cancel that to a 2. So my final answer is x squared plus 5 to the 4th power over 2 plus c. And that's what happens when this doesn't match. So I'm going to take another color, like this fluorescent. I don't have a fluorescent blue, but I've got a blue. When these two do not equal, you got to make them equal. Now, I will tell you, out of all the antiderivatives, substitution is usually the hardest one for people to get. Kind of like F on a guitar, right, Mr. Nicolini? F is hard for some people. So there's 2 ways to get good at holding F on a guitar. One is to quit, and the other is to practice. So if you think you're going to suck at this, then you're going to have to practice it. Let me ask somebody, anybody that want to volunteer that they took calculus before at another school? Anybody, or here and didn't do well? Anybody? Anybody?
I took
okay,
it here
Mr.
and didn't do
Nicolini,
well.
do you remember this when you took it?
I don't think I made it that far.
Okay. Does anybody remember making it this far?
I remember this, but I didn't know what to do.
You didn't know what to do. See? All right, so you got 2 problems so far. One is the one we just did, where it matches. And then one where it doesn't match. All right, let's do a nerd. I will tell you right now, this one does not match. The antiderivative of e to the 5x minus 3 dx. Now, I added those parentheses for a reason. Some of you might think, well, E is complicated, so I'm going to let U equal E. No, 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 no. E never is going to be equal to U. Usually, and I'm going to put this in red, usually your x terms go to u. Okay? Most of the time, your x terms are going to go to u. You're not going to say u is equal to e to the, no. And that's why I put those parentheses here. So I want you to tell me what you think u is. I want you to do it. I want you to find du and see if you can work this problem out. Go ahead. Take a minute. And I gave you a hint with the parentheses around the 5x minus 3. So hopefully you know what u is now. So what do you think u is going to equal?
5x minus 3.
Good job. U is equal to 5x minus 3. Therefore, du is equal to what?
5.
5 what? Dx. So I've got to put a 5 here. So that means I've got to put what on the outside?
1/5.
1/5. And now I have 1/5, the antiderivative of e to the u du. And what is the antiderivative of e to the u? It's the easiest antiderivative and derivative to do in calculus. What is the antiderivative of e to the u?
E to the u.
E to the u. So my partial answer is 1/5 e to the u plus c. And now what? 1/5 e to the 5x minus 3 plus c. And I'm going to take my blue marker. No, yeah, blue. As long as these two match, then you're on your way to finding the derivative. These two have to match. Now, I can promise you this, you do not want to look at the book about doing these. Does everybody understand what I'm talking about? Why do you not want to look at the book? Because you will be lobotomized. If you try to look at the book and you try to see what the book says, you're going to come into class Monday or Tuesday slobbering all over yourself. Okay? Don't look at the book unless you understand it. And if you understand it, more power to you. All right, let's do a nerd. And I know you don't want to communicate with me, but if you got a question, ask. That's a pretty picture behind you, Miss Qualls. That's a real pretty painting. Did you do that yourself? Oh, well. Thought I'd get some answer. Antiderivative of 8 cosine of 4x dx. All right, I want you to do it. Don't worry about the cosine. You got a cheat sheet for the cosine. Don't worry about that. I want you to focus on u and du. Rewrite it. You need to rewrite this because it's not in the way that you want it. Okay? That 8 needs to go with that dx. And then I want you to find u and du and see if you can make it match. You rewrite it. Cosine 4x 8 dx. Did I put those parentheses there on purpose? Yes. To give you a hint. You're not going to make, now there are some times that you will make u equal to a trig function. So I'm not going to tell you you're not going to do that. But here, you got an x function here, you're going to use it. So u is equal to 4x. Du is equal to what? 4 dx. We don't have 4 dx. We've got what? 8 dx. How do I make a 4 dx into an 8 dx?
1/2.
Multiply by 1/2, which means I've got to multiply the outside by what?
2.
2. Now I have 2 times the antiderivative cosine of 4x 4 dx. Now I have 2 cosine of u du. And somebody tell me what the derivative of the cosine is, looking at your handy dandy handout.
Sine x plus c.
Yep, I'm gonna pull it up just so everybody can see what I sent them, because I know 75% of the class didn't pull it up. The derivative, the antiderivative of the cosine is the sine. So 2 sine of 4x plus c. Now let me ask you, Mr. Piella, is this doable?
It is.
Compared to last semester, I mean, is it doable?
Yeah, it makes more sense now because like you explained it. The previous professor didn't explain it, so
They just went through and did it, didn't they?
yeah, they just went through and did it.
Okay. All right, I'm going to give you another one. And we're going to do this Tuesday also. We're going to do this over and over. I'm going to drill this till you're dreaming about it. Unless you don't want your money's worth. And if you don't want your money's worth, then I'll just go through it. And then y'all will not know it for next semester.
No, don't do that.
X to the third, you're not supposed to communicate. E to x to the fourth dx. Rewrite it. Rewrite it. Now, you know you're not going to put E with the dx, so that means the x to the third is going to go with the dx. Now, I'm going to let y'all do it because I really feel like some of y'all can do this now that I've shown you how to do it. Mr. Piella is trying to get his picture on front of TCTC website by sitting out there doing work like Mr. Lowry did. We know you're trying to get your picture taken. What?
I need my vitamin D.
Yep. You want to get your picture taken. You want to be Mr. Tri-County Tech. That's what you're trying to be. Get you a brick phone. Go see if you can find you a brick phone. That way you can be Mr. Tri-County Tech.
A brick phone?
Yeah. Because some of Tri-County Tech believes they're with technology and they're using a brick phone. I mean, they're not.
Yeah.
All right, somebody tell me what U is going to be equal to.
X to the fourth.
X to the fourth. So get my green pen and my orange pen. U is equal X to the fourth. Therefore, du is equal to what?
X to the third. 4x.
4x to the third dx. So we need to have a what here?
4.
We need to have a 4. So therefore, 1/4 is going out here. Now we have 1/4 antiderivative of e to the u du. And somebody tell me what the antiderivative of e to the u is.
E to the u.
So our answer is 1/4 e to the u plus c, which is 1/4 e to the x to the fourth plus c. Y'all feel so comfortable and good about yourself right about now? I guarantee you there's a student out there that didn't do well in calculus, and they're like, oh my gosh, I can do these. But they're not going to say anything. That's okay. All right, y'all ready?
Let's go.
Antiderivative of the square root of 7x plus 6 dx. I'd just go ahead and quit on this one. Why would you quit on this one?
12 root.
It's a square root. You don't know how to do no square root. Might as well quit. Right, Miss Hightower? Too complicated. She's not talking to me.
Exactly. No, I had some malfunctions just now.
I have a feeling Miss Hightower likes to talk. Don't you, Miss Hightower?
A little.
Yeah, I didn't think you were winged on a pickle. First day you talked to me, I remember that. You're going to have a nice office one day, Miss Hightower.
I hope so.
Just keep communicating and you'll be okay. Same way with a relationship. I don't care what kind of relationship it is. I don't care. Friends, more than friends. If you don't communicate, it sucks. It's just like that date. Where do you want to go eat? I don't know. Where you want to go eat? That kind of crap. That's the mind games crap. If you want to go get a hamburger, you say, I want to go get a hamburger. You don't play that mind game.
It sounds like you've been affected by that before.
Yeah, big time.
I'm just playing.
Yep. All right, so I gave y'all another hint. I keep giving y'all hints. So what is U equal to?
7x plus 6.
U is going to be equal to 7x plus 6. Du is equal to 7 dx. Therefore, I've got to put a 7 right here. And I've got to put a 1/7 right there. Now I'm going to rewrite this, and you can rewrite it before, it doesn't matter. I'm going to put a 1/2 exponent. So 1/7.
So I have a question about du.
Yes.
Is it always going to be the coefficient of u? Like, for instance, u is 7x plus 6. So the coefficient of x, is it always going to be the du?
Well, sometimes I might have u is equal to x squared plus 3. And du would be 2x. So, no, sometimes it'll be different. There'll be different things. We're going to build up to that. Right now, we're on training wheels. Okay? Tuesday, we're going to get into a little bit more. We're going to take the training wheels off Tuesday. Okay? So, antiderivative of u to the 1/2 power du. That's what we got. U to the 1/2 power du. So what is the antiderivative of u to the 1/2? U to the 3/2 over 3/2 multiplied by 1/2. And somebody crank that out. What do you do with that 3/2? Multiply by what? 2/3? Wait a minute. That's supposed to be 1/7. It's supposed to be 1/7. I'm sorry. Sometimes I can't read my own writing. That's supposed to be 2 over 21. So 2 over 21 u to the 3/2 plus c, and that's going to be 2 over 21 7x plus 6 plus c. I guarantee you there's somebody out there that got that right, and they are like, I can't believe I got that right. Substitution is not a big deal. Have you noticed how I do every problem? How do I do every one of these problems? I follow the same what? Really?
Process?
I follow the same process. I don't start reinventing the wheel. Okay? I don't start skipping steps. I do the same process every single time. All right, let's do a nerd.
It's 1:15.
Dadgummit. Okay, well, we'll have to stop. I only had I have like 3 other problems to do, but we'll just have to wait. Y'all can work on 5.1 through 5.5 now and start sending questions. And I'm going to shut her down, and y'all have a good week, good long weekend. Y'all get Friday and Monday. Maybe we ought to have voluntary class on Monday. What do y'all think?
Are you gonna shoot fireworks?
No, I hate fireworks. I did all my fireworks